welcome to my talk about reproducible and ephemeral development environments with Nix for our Golang projects. A little bit about myself. My name is Haseeb Majid. I'm a backend software engineer at fintech called Curve. There's a link to my blog. A few fun facts about myself: very like cats, and I'm an avid village cricketer, bold and underline on the village part there. But I'm looking forward to the cricket season starting in the next couple of weeks or so. It'll be good to get outside. So who is this talk aimed at? It's aimed at a few groups of people. The first group being those who are kind of interested in Nix and want to learn a bit more, and for sure we'll cover that. It's also aimed at those people who are looking to improve the developer experience, particularly around the consistency of the development environments. So things like going back to an old project like 6 months ago that you haven't touched and you're worried that you're going to spend a half a day yak shaving getting the development environment working. You're going to want to, you're not going to want to faff around with that. You want to just get on building features, bug fixes, adding tests, whatever you want to do, right? Work on actual code. And so we'll take a look at how we can use Nix to help with that. We'll also look at how we can make it easier to onboard new developers so they have to type 1 or 2 commands just to get set up on a project. And especially if we can have consistency across lots of our projects, imagine at work, then it means that developers kind of know they have 1 or 2 commands to write and they can jump between projects really easily and, again, get coding as fast as possible. Then also, we don't just want things to work on our machine, we want them to work across everywhere we run this. So whether that be locally, CI, or even say like your various environments that you have, production, dev, etc., etc. And we don't want to annoy Samuel Jackson, do we? We want it to work everywhere. We don't want it to just work on our machine. So some of you probably wondering, what's Nix? Nix is a declarative package manager, and we'll cover what declarative means in a second. But package manager in the sense it's a tool for installing packages on our machine, which is kind of, especially as a software developer, kind of a fundamental thing we need to do on our machines is install packages. It's similar to tools like apt, pacman, or brew that you may be familiar with. It's powered by this thing that I'm going to call Nixlang. You may hear it called the Nix programming language, and it's this pure functional and lazily evaluated language. And what we mean by pure and functional is that it doesn't have really side effects. It does have like 1 or 2, but basically for the same input has the same output. It doesn't really depend on the state of your machine. So it means if we have these like Nix configuration files, we can kind of easily move them between devices and people. Because it's not really relying on the state of your machine, which is quite nice. And lazily evaluated in the sense that it just works out kind of the bare minimum it needs. It's lazy. It's just like, okay, I have enough information to go build this package. I don't need any more. And that's particularly useful. We have 80,000 packages in the Nix packages repository. We don't want to build all of them, for example. We just want to build the ones that we need for the packages we want, right? There's also this thing called NixOS, Linux distribution that's powered by Nixlang and can be configured using Nixlang, and it's also powered by the Nix package manager. We're not really going to talk much about that. I do daily drive it. It's pretty cool, but just know it's separate from Nix. You could have, like, say, an Ubuntu machine that's running the Nix package manager. So when we say something is declarative, what we mean is that we kind of just care about the final state of things, whereas typically package managers are imperative, where we're giving it like step-by-step instructions. So for example, if I was to say, make me a cup of tea, and then I gave you instructions like, get the tea bag, turn on the kettle, etc., etc. That would be what you might classify as imperative, whereas declarative is just me saying, can you make me a cup of tea with milk and sugar? And then you kind of work out how to get to that final state. And it's very much the same with Nix. In this case, we have the sway tiling window manager that we want to turn on, and we want to turn off the i3 window manager. We're not telling Nix how to do that. We just say this is the final state, and Nix goes off, runs off, and does that. One of the other cool things about generally when things are declarative is we often put them into code, and then we get other benefits like version control, easier for people to review, easier to reproduce as well, because again, it's not really caring about the state of our system. If I don't have i3 installed, for example, Nix will just work this out fine. It just won't uninstall i3. It's pretty cool, and I think it's definitely a really useful feature of Nix. And then once will have converted you to Nix, you can start busting this out into conversation. Say, by the way, I use Nix, to your friends, and just doesn't matter what the conversation is, you can always change it. And I'm sure they won't mind. at all. So what's the problem we're solving? Well, imagine like typically when we have binaries installed, we might have them in user local bin, like Golang CI-lint. There are a few problems that the typical package managers have. It's like, what dependencies does this need, like runtime and build time? Like, how easy is it to discover that? What configuration flags was this tool built with, and environment variables, right? If you wanted to like build the same version yourself, how do you do that? And then how do we have two versions of this package? What if we need to have version 2, for example, and version 1? Now, as far as I'm aware, Golang CI-lint doesn't have a version 2, but it might. And for some projects, you might want to use version 1 until you've upgraded it. And for some projects, you might want to use version 2. How do you do that? Because typically our package managers replace the binaries in place, right? So we replace this with version 2. So how do we maintain multiple versions? And there's various packaging solutions that kind of solve some of these problems. You have like snaps and flatpaks, which create these sandbox environments, and they have their dependencies, I believe, in these kind of sandbox environments, and they don't really interact with the rest of the system. We have ASDF for managing like multiple versions of some of our tooling, like Go, Node, Python, etc., etc. We have virtual environments, and to a certain degree Go modules, so we can have like per project dependencies, and we don't need them like globally installed. More so for virtual environments than Go modules. But yeah, virtual environments used in Python, for those of you who may not know. To kind of summarize this section, we want to have reproducible and ephemeral environments. Nix is an ecosystem of tools. So we have like Nix, NixOS, Nix packages, the Nix programming language, right? The main thing, of course, being the package manager. And then our current packaging systems all have various flaws. There's nothing in software engineering that's a silver bullet, Nix included. It can be a bit complicated, Nix. You kind of have to learn this programming language, which puts people off. But I think the upsides beat the downsides of Nix, in my opinion. So if we take a look at this demo, we look for this Golang CI-lint binary. Can't find it. We go into this project, we load this dev environment, and then when we look for this binary, we can find it. And when we leave this project, we will no longer have this. And this is kind of the state we want to get to. This is kind of what we want for our developers, and we want to make sure that people are getting the same versions of tooling as everyone else. So in this case, I think it's version 1.56.2. We want to make sure all the developers are getting that same versioning. And when I say ephemeral development environments, what I mean is short-lived, temporary, in the sense that just existing for the life cycle of this project. And when we leave it, the environment's kind of gone or not loaded. But yeah, so that's kind of what we're going to achieve, and we're going to take a look throughout this talk how we can achieve that. So how does this relate to Golang? Well, with Go, we need tooling to aid development, right? Like we might need binaries to generate code coverage reports. We may have tools to vet our code, static code analysis, container code analysis, all these things that go into development, Docker and Docker Compose. We have, dependencies for our projects, and we're not really going to worry about those, that we manage via Go modules, i.e. our Go mod file, but the other tooling we need to aid our development. Maybe we have a task runner, like we have make files, right? Like we might do make lint or make test. And we want to make sure developers have similar versions or the same versions if we can. And we want to make sure the same versions are running in CI, they're running locally, because I'm sure we've all been bit by the bug where it fails in CI, is working locally, and it's just because of a version mismatch. Couldn't say that word for a second. So one way we can kind of do this is, and we do the set curve for some of our projects, is we have this tools.go file. And essentially what we're going to do here is we're going to manage our dependencies using Go modules. So we install these various packages using Go modules. And then we add these underscores here to trick Go modules into thinking it's imported. So if you do a Go mod tidy, it doesn't remove these. And the cool thing is then they're all kind of managed via Go modules, and we can do an update. We just update one file, and it will update our dependencies and etc. Right? It's quite nice, and we have this build flag, so it doesn't get built with our binary. And that works for Go dependencies, and we maybe have a make target like this, which installs these dependencies in our Go path bin folder, which works. But then we encounter similar problems as what we were talking about before. What if between projects we have version 1 of one tool and version 2 of another tool? We kind of have to remember then to run this tool, which is going to overwrite the binary in that Go path bin folder, right? There's something else we have to remember to do when we're jumping between projects. And then what if we want to manage tooling not related to Go? What if we wanted to make sure that the user has GNU make or GNU Parallels or some other CLI tools, and maybe we have some bash scripts or something, and we want to make sure certain tooling is available in that. And so I think this is where Nix can come in and fix a few of our problems. So let's take a look at how we can create a development environment in Nix. So imagine we have a project like this, really simple Go project. How are we going to create this Nix environment? Don't worry about the syntax of Nix and what's kind of happening behind the scenes. We're going to take a look at that just later in this talk in a couple of minutes. But first, we're going to take a look at how we can create this development environment. So we have this flake.nix file. Think of it as a main.go file. It's the entry point to our kind of Nix configuration. It has a bunch of inputs and a bunch of outputs. In this case, our inputs are all basically going to be Git repositories. So one of them being Nix packages, which is this repository that has 80,000 packages. So this is where we're going to install our packages from. Has a bunch of outputs. Nix flakes can output a lot of stuff. They can build a Docker image. They can build an ISO. They can create a development shell, which is what we're going to do, dev shell. They can build a package. They can do lots of various different things, but we're really just going to focus on dev shells today. But it's just good to know, generally speaking. So we have this helper library called flake.utils, which basically just reduces some boilerplate in our Flake, where obviously packages have to be built for specific architectures. So, like x86, 64 Linux, or Arch Darwin, it's like AMD and Intel versus ARM-based chips, different architectures. So we have to build the binaries differently. And so packages are built, we have slightly different packages. So basically what we're doing is we're just specifying that we want to just get the packages for our system architecture. And flake.utils lib is this library that helps us reduce the boilerplate to do that. But that's basically all we're doing here. So don't necessarily worry about that. Here, what we're doing is we're creating a default dev shell. We have this packages.make shell function. So between the kind of curly braces is this function, and we're passing a parameter called packages. And these are all the packages we want to make available to the user of this dev shell. The details again don't matter too much. I just took that from a project I had called flake.nix, which I've linked later on. You can take a look at that. So we take a look at, so how do we use this? Well, if we kind of look for the binary, we won't find it. It's fine. Then we do nix develop, which will load our development shell that we just created there. And then when we look for our Golang CI lint binary, we can kind of see at this funny path, nix store, some funny characters, hash maybe, and then, yeah. Cool. So we've created a development environment. So if we kind of summarize what we've done so far, well, we can leverage flakes and dev shells for installing packages. We can load into those shells or that shell using nix develop. We can make sure each developer gets the same package. We have this concept of this flake.lock file, which locks our inputs. And we'll take a look at the syntax of that and how that works a little bit later in this talk, but just keep that in mind. And we can update this lock file, but we have to kind of manually do it. So one other thing that's quite cool is we can use this, again, Nix agnostic tool called direnv. And with direnv, what we do is create an mvarc file, and what we put in this mvarc file will get executed when we load into this directory automatically. So what we can do here is do this use flake, which is kind of this helper function for running nix develop automatically. The very first time we load into a directory that has direnv, we do have to, has this mvarc file with direnv. We do have to approve it, so we don't just run arbitrary code on our machine. So let's take a look at what that looks like. So imagine I'm at work and I need to add a feature to a project. I clone this example project. I try and find this linter. I want to lint the code, right? Can't find it. Fine. I load in, I do direnv allow, because remember that first time we have to do direnv allow, which has this use flake. It will load in this dev shell. In this case, it's already cached. It doesn't need to do anything. It can just load in one that I already had. Then in my case, because I'm using Starship prompt, and I'm sure other prompts do this as well, it will let me know that I'm in a development environment here with the via, and it has that little flake, which is quite nice. Just a good reminder that you're in this kind of a dev shell. And then when we look for this binary, we can find it. When we leave this folder, we can't find it anymore. And so that's, again, that ephemeral nature I was talking about. And one of the cool things about direnv is the first time you go into a directory, it'll tell you have to do direnv allow. So it's not something that you have to remember. It will tell you, and again, you only have to do it once. Next time I go to that directory, you won't have to run that again. One other thing we can do with direnv and nix flakes is we can point to a dev shell or some nix config that has a dev shell in a remote repository. In this case, it's on GitHub, and we can use that if we want. So we can share configuration, and we could use multiple flakes as well if we wanted to, but we're not really going to get into that for this talk. But just to know, if you want to have a remote development environment, you can as well. Or the config remote, you can use that. One other thing that I think can really improve the developer experience and something we can manage with Nix is pre-commit. So, we have these things called git hooks, which is these arbitrary scripts we can run at various stages of the Git process, like pre-commit, post-commit, pre-push, post-push, etc., etc. Then there's this tool which can be a bit confusing, as in it's a bit confusingly named, called pre-commit, which will basically help us create these pre-commit git hooks for us. So we can create this using Nix. So if we do pre-commit hooks, add that as input. Again, you can name these inputs whatever you want. It just helps to kind of make them somewhat related. We add that into our output section here and say we want to create these pre-commit hooks. It has some built-in hooks for Go that we can use. So we use Golang. We're going to enable the linter, and we're going to enable tests. And the cool thing is it will only lint and run tests on the files that have changed, as in the ones we're trying to commit. And so, yeah, we get some really fast feedback when these run. It saves us time waiting for CI and saves some credits as well, build time. That could go used for somewhere else. Then we can add the shell hook to our make shell function that we had. And the shell hook is just a command that will run automatically when we do nix develop. I'll load into the shell, which is going to happen automatically when we're using direnv. So essentially when we go into the folder, it's going to install our pre-commit hooks for us, whereas normally the developer would have to remember to run the pre-commit install. Like it's another command they have to do, and now they don't have to think about it, which I think is really cool. And with these pre-commit hooks, you can get some, again, really fast feedback. So it closes that kind of feedback loop and lets the developer know something's going wrong or not. To kind of summarize this bit, what we've done, we can use direnv to further reduce cognitive load on our developers. We can use flakes from remote Git repositories, share them between multiple projects if we want. We can also manage pre-commit in Nix. Just something to note that pre-commit is usually managed using a YAML file, and now we're using a Nix, and some people do have an issue with abstracting away from the original way we configure a tool. I don't mind it, but perhaps just something to consider. So kind of the next section I want to cover is how does Nix work? Like what's happening behind the scenes? So everything in Nix is an expression, which I believe is quite common for functional programming languages. Remember, this is powered by Nixlang. And so what we have is we have a file, maybe it's called shell.nix, and this will get imported somewhere. And we have this function essentially here in this file that takes in one parameter called packages. And then we have these triple dots, which ignore any other parameters passed, right? Then we have this function call called packages.makeShell, and we pass it a bunch of packages we want to install. So in this case, this Nix expression, we kind of return one Nix expression from the file, which can be a compound of other Nix expressions kind of put together, but we always return one. So in this case, we're returning this function. And again, this file will get imported, and during the import, you'll have to pass packages. And yeah, we were kind of doing this with our flake.nix file, but it was a little bit more hidden, I guess, what was going on. But that's kind of what Nix is and kind of what we're doing here. So you might be wondering, like, okay, what's this Golang CI lint? I get it's coming from Nix packages, but what does that mean? Well, on Nix packages, the GitHub repository, we can go find the Golang CI lint Nix expression, and it has this function called build Go module, which is a helper function for building Go modules. And you can see it has like a name, a version, where to fetch it from GitHub. It has a bunch of other information about how to build it and if it has any dependencies, etc., etc. So we have this Nix expression there. Cool. If we dive a bit deeper and look at what's behind the build Go module, it abstracts away the standard env make derivation, where this derivation function is the most important built-in Nix function. So when we're building packages, what's actually happening? It's a two-step process. So when we do Nix develop, behind the scenes, it'll be calling like Nix build of some kind. And behind the scenes, it'll be doing this in two steps. And you'll see why we do this in two steps. So the first step is evaluation time. We take the Nix expression, so the Golang CI lint expression, and we return a derivation set. this DRV file, where a derivation set or derivation is just a set of instructions how to build a package, kind of like a recipe. Then we have this build time. The derivation is built into a package, and that is what has a side effect on our machine where stuff is actually getting installed. So let's take a look at derivation. So derivations are put into our Nix store folder. They have the format hash, name, version, DRV, where a hash is a cryptographic hash of all the inputs to that derivation. So let's say we have this Go 121.8 derivation. Even if we're building Go 121.8, let's say we change an environment variable, we are going to get a different cryptographic hash there, and so we're going to get a different derivation. And for all intents and purposes, it's a different package as far as Nix is concerned. So derivations and also packages are mutable. I mean, you can obviously go change them if you wanted to. Nix discourages you from doing that. You probably shouldn't, but you can if you really want to. Let's take a look at what this derivation looks like, and we can run this command at the top there. Don't worry if some of this is cut off. It doesn't really matter. It's more just high level what's going on. So we have a builder, how we're going to build it, bash. We have a bunch of environment variables. These are the only environment variables made available during the build. We have a bunch of input derivations, so other derivations this depends on, and Nix will make sure these derivations are built into packages before. Then we have a bunch of metadata, where this package is going to get installed, what system it's for, name of the package. Then we have this package, which again is immutable. So if we wanted a different version of this package, let's say environment variable changes, it would be at a different path. And you can think of the path as a unique identifier as far as Nix is concerned of a package. And then there's some symlinking done later, which will determine which binary we end up using, even if you think they're basically the same. And then within Nix store, we kind of have everything we need. We have the binary, we have share go, and has a bunch of other stuff, which is quite nice. Because our packages are immutable, and we can kind of pre-compute them. So Nix has a bunch of servers available to it that are kind of pre-building these binaries and packages. And so what that means, if a derivation says we need to build a package at this path, we can check if that package exists in our path. If it doesn't, we can go fetch from various different caches. In this case, I'm fetching from the official NixOS cache. And the cool thing about that is often, because these are being pre-built, and you can pre-build them yourself as well if you want, and you can pre-build your own packages if you wanted, it just means we just have to fetch them and download them. We don't actually have to build them ourselves on our machine, which is really cool. So often we're just downloading stuff. We're not actually building because lots of these packages are pre-built. Another advantage that this kind of approach gives us is that the dependency tree is explicit, and we can see what Go depends on and then what those tools depend on. So like it depends on bash, and then bash depends on glibc, and anyone with this exact same unique identifier, as in, starts with K7, CH, etc., will have the exact same dependencies as us if we print out this dependency tree. And Nix store basically becomes this kind of graph database of our dependencies, right? One other thing that doesn't matter so much for specifically for dev environments, but it's kind of useful to know, because of this approach of we're not updating stuff in place, we can kind of have this concept of generations and profiles, and we can roll back to earlier versions of generations. We can also then have atomic updates if we want. We do have atomic updates, and that basically means that if something fails during the update, we can go back to an older version, or we don't even end up updating the Nix profile at all, because these binaries just end up getting mapped to stuff in Nix store. And yeah, unless we garbage collect and clean up stuff, it's kind of going to be there. One other thing to note is you'll notice that we use an epoch time of 1, i.e. 1st of Jan 1970. The reason for that is because the timestamp date time can be a form of non-determinism, because sometimes that gets injected into the binary, and what we want to make sure is that we build the exact same binary. Otherwise, every time you build a package, you get a different binary, and so wouldn't, we don't want that. So we set this to 1970, and we make it a deterministic timestamp. Then in the Nix world, this is what bincat looks like. Not user bincat, but in Nix store. So to kind of summarize, Nix derivations allow us to have immutable packages, require us to make our dependencies explicit. One thing to kind of note is if a package is not in Nix packages, you will likely have to package it yourself. But because Nix packages has 80,000 other packages, often or always I've found that if I need to package something, it's just that one thing. The dependencies it needs is almost always in Nix packages itself. The next bit we're going to cover is Nix flakes. So how does Nix flakes relate to stuff? So Nix flakes basically take state on our system and kind of put them into code. In the sense that we have these things called Nix channels, which would refer to what version of Nix packages we're pointing to. And what we do is we just take that and make that kind of more explicit, and we'll see exactly what that looks like. With this flake.lock file, we lock our stuff to specific revisions, and that means because we can put that lock file in code, other developers can then point to the same inputs. We can also use other Git repositories, non-Nix related, and manage them using our flake.nix file. If we want. They also define some basic structure because now our flake.nix file becomes the entry point for our Nix configuration. So that's kind of the first file you can go to look for that Nix configuration. So as we said before, we have a bunch of inputs, a bunch of outputs. The main input being Nix packages, or the default input we get when we initialize our flake. Then we also generate this flake.lock file, which has this kind of concept. So this is the lock for the Nix packages input. We have this nar hash, which is just a hash of the contents of that input. Less important because it's a Git repository, but we could have non-Git related inputs. In this case, we also have a revision. So anyone using this flake.nix and flake.lock file combination will be locked to this revision until we update that lock file. And that means if we're using this in CI or other developers are using this, we'll be pointing to the same version of Nix packages, which is really cool. We can also use, let's say, a GitHub action or CI to update this flake.lock file for us if we want. Think a bit like Dependabot style stuff if you want to do that. To kind of summarize, Nix flakes improve reproducibility across our system by locking our dependencies. They provide a more standard way to configure our system, but do note they are an experimental feature in Nix, and they could break in terms of they could be breaking changes. So just keep that in mind. But I think they're great, and I use them in all my projects and my own Nix configuration. So kind of one of the final topics we're going to touch on is CI. We've spoken about we want consistent environments between what's running locally and what's running in CI. How can we do that? And definitely we want to kind of leverage Nix's cacheability and sharing dependencies. GitHub Actions has some great stuff, especially from, I think, determinate systems for leveraging caches and various things to speed up your pipeline. I use GitLab CI, and I found this great project by this user called CYNerd, and it has this Nix job, and what it does by default is leverages the GitLab cache, but we could use a cache from an SSH machine as well. Or SSH to a machine and copy from there. But essentially what it does is before and after the job, it'll just copy from the cache to the Nix store of the job, and then from the Nix store to the cache. So it shares dependencies between different stages and different jobs. So in our GitLab CI file, we include this GitLab CI file, the GitLab project we just saw. Then I have a stage called pre that extends this Nix job, and we just do Nix develop to install our dependencies. Then at a future stage, dependencies have been cached. They'll be copied over to this job, and we can do Nix develop C, Golang CI lint run. Whereas normally we'd be in that Nix development environment, and we could just do Golang CI lint run, and we should be running the exact same versions because of the nature of flake.nix and the various things we've talked about with Nix. So that's really cool. And this is kind of what it looks like. 11.5 minutes total runtime. I think before I did this change, it was 22 minutes. Rather anecdotal, but something to note. Kind of just taking a look at our CI logs. Again, we can see it's copying from that cache, which is really nice as well. And this was definitely me with Nix when I first heard about it. I didn't really get it, and then eventually it clicked, and I think it's really, really cool. And hopefully you guys either think that at the end of this talk, which means I've done an amazing job, unlikely, but I'd recommend just giving it a go and seeing what you think. But before we close out this talk, I'm sure some of you have been thinking, or maybe even screaming at your computer, why not Docker? And I definitely was confused, like, how does this relate to Docker? So remember, we're talking specifically for Docker in terms of like as a development environment. I think Docker's still great for building and packaging and deploying our stuff, especially on the cloud. And specifically what I'm talking about is Docker files to build Docker images. And one of the problems Docker has, I think, by being imperative, you'll often hear the term it's repeatable, not reproducible, often because of the package managers we're using. But imagine you have a Docker file. If two people try and build it like 6 months apart, you're probably going to get a different Docker image, and therefore it's not reproducible. One other problem I have with, say, Docker dev containers, which VS Code plugin, which I think now works with JetBrains as well, to try and make it easier to develop within a container, is what if I have specific tooling that I want? I now need to make that available, like say FZF, Zoxide, I have a specific shell. I have to make that available in the Docker image, and I'm potentially bloating that Docker image as well. I did find a way to personalize it. You can kind of run this startup script, but that was a bit slow and a bit more cumbersome than I found comparing it with Nix dev containers. Nix dev shells. It's just something to note there. Give both a go, see which one you prefer, but I think I found Nix a lot easier. A few things you can look at in your own time to further use Nix even more, like Nix all the things. Here's a link to my slides. I'm going to have a bunch of other links. Just go through them in your own time. Just lots of literature and articles and YouTube videos. Want to give a shout out to Vimjoya. Specifically, they do really great videos on YouTube. Highly recommend checking them out. And just a thanks to everyone who gave me feedback on this talk and improved it a lot better than it was, I think, version 1. And thanks to Conf42 for giving me the chance to talk about this. I really like talking about Nix and want to share it with other people to see, let them know what they can do. And thanks to you, of course, for sitting through this talk and listening to me ramble on about Nix. Hopefully you found that useful, and you'll give Nix a try. Thank you very much. Have a lovely day and enjoy the rest of the conference.